I'm Aryan from CIMD Solutions, and we're here to pitch to you a new generation of energy absorbers. So crashes are a well-recognized and well-documented problem prevalent within machinery, and by nature, they're often erratic and chaotic. The effects of crashes lead to long-term health effects, physical therapy and rehabilitation, added strain on the healthcare system, and also lost work time, totaling to an economic expense of over trillions of dollars annually. And despite over half a century of research and innovation in this field, the first line of defense hasn't really changed. We still use thin-walled members implemented within the machinery to crush and absorb energy, and this crushing behavior is inherently what causes this erratic nature. So our solution is to introduce the exact same energy absorption structure as the thin-walled members, but rather than crush them, we want to introduce a cutting tool to split them to get a more controlled, steady, and more desirable response.
So on the left, you would see the typical, we call it the crushing force, but ultimately what it comes down to is that deacceleration profile that you as the occupant would experience if you're in a system using the current state of the art. On the right is the response from our novel cutting-based solution. Now, certainly you can already see that our solution is much more consistent, but there's some very important breakthroughs that have come out in recent years. Now, first and foremost, that average load bearing capacity, that benchmark for how much energy can be absorbed, how high speed of a crash we can tolerate, we can meet, if not exceed the requirements with the same structure subjected to cutting rather than crushing. Now, also with this, equally important, we're able to take that excessively high peak value, sort of that amplitude, if you will, and bring it down to the point where it's almost at the same level as the average. So in plain English, this is effectively the performance gap which we're closing. And by doing this, we're able to almost all but eliminate that primary source of death, serious injury, and long-term effects. Now, the opportunities to implement this tool are essentially beyond count. Everywhere where you have machinery, from research to transportation to defense, you're going to have energy absorbers by nature. Even conservatively, these industries are valued at billions of dollars. Now, these fixed barriers that we're describing, buffers, roadside barriers, what have you, they're typically the case for crash. So for a new technology, there's some proven ground. Now, following further maturity of the product and proving itself in these scenarios, there's further opportunity to sub-license this technology. This is the point where companies in the transportation sector, be it Oshkosh with defense vehicles or GM and Toyota with cars, they can implement the cutting system into their vehicles. And over time, effectively, there's an opportunity to put the cutting technology into every piece of machinery on the planet. Now, that higher average force capacity that we described, coupled with the fact that you can cut for longer distances than you can crush, another important implication of the research is that we can meet current energy absorbing requirements with a 40% lighter structure than the current state of the art, which has far-reaching effects. Certainly, lighter structures have less energy in their crashes, which means we can significantly temper the death and serious injuries that we've outlined. More efficient production is another direct benefit at all levels, from shorter processing times, less material use, lower shipping costs, and even the ever-growing and ever-important problem of electrifying transportation and reducing emissions. Crash systems tend to make up a large portion of the mass in vehicles, and so by bringing down that mass by 40%, we can make a significant dent in the carbon footprint of these sectors just by tackling crash.
Our proposed business plan is to take a B2B approach. Customers will come to us with their applications and requirements, and with us leveraging on over a decade of mature research, we're able to design a custom tailored solution to meet their needs. Following the design phase, we are able to manufacture and integrate our technology into their product. Following successful completion of the job will lead to future business opportunities as well as repeat business. So our go-to-market strategy for the first 2 years is bringing in funding as well as a marketing consultant and developing a catalog of commercial off-the-shelf solutions. The third and fourth year is all about starting a small volume of orders and scaling the operations. And the fifth year is all about executing long-term contracts and revenue. In terms of projections, the first 2 years is bringing in funding to start up the business. The third year is about executing small volume of orders and bringing some revenue from that. And then the fourth year is about scaling the operations and continuing to grow the business. The fifth year is where we project our break-even point to be, where we are able and have the capacity to complete long-term contracts. This is our proposed team with room to grow with a marketing consultant, sales director, and technical support staff. Thank you for listening to our presentation. If you have any questions, please feel free to ask.